Unmute. Participants, security. Enable waiting room. Disable waiting room. Share screen, chat, rename themselves, unmute themselves. All right. So as we get going, anybody that comes in late or is unable to attend, I can send them the recording at the end, or you guys can post it wherever you need to. So let me go ahead and start since we're on kind of a limited time frame. Again, for those of you that don't know me, my name is Richard Frederick. I'm an instructor. I teach business analysts and product owners and project managers and scrum masters, specifically courses around requirements and project management. Anyway, that being said, last month we did a really short lunch and learn about dashboards and robots. And in that presentation, I was trying to get people to sort of recognize that the future is data. And the reason it's data is because of intelligent assistants who are ultimately going to become a member of your team. And traditionally, as business analysts, we are trained to elicit requirements predominantly for product and process, but there's not really formal training around eliciting requirements for data. So I'm hoping to sort of fill that gap. Now, if you're in the business of eliciting requirements and you are struggling, don't feel bad because everybody struggles. This slide right here just goes to show you that nobody has all the answers. Everybody's got a little piece of it all over the place. So I went through all the different standards that I could and just tried to pull out what's relevant to what we do as business analysts. And so in this section, I'm going to kind of move very quickly because again, I'm a little bit behind schedule here and talk about what are structured requirements. So let me just kind of go to this. So this is really kind of the nuts and bolts of what we do is structured language requirements. And again, I tell anybody that, will listen, this is the hardest part. Well, eliciting, I should say, structured language requirements is the hardest part of what we do, I think, in my opinion. And it's difficult because of the way humans communicate to each other. We have a very nuanced language that has to be converted from a very, ambiguous, complex, nuanced, subtle language into very specific, testable statements. And what's kind of interesting is the literature that we are trained on as business analysts takes us down a journey, and for those of you that have been on that journey, it's elicit, analyze, document, and then validate. Validate is kind of like testing, but without really doing testing. It's getting feedback from your stakeholders about whether or not the requirements were written properly. And my experience has been that there's no wrong way to write requirements. There's an infinite number of ways to write requirements. And the real challenge is, do they work or not? That's really what it boils down to. Are the statements that we're writing, do they actually work once they get to a testing stage? So for all these years, I've been training people on validating requirements, but I realized just through my own experience of owning a software company that what's really critical is that as an analyst, you at least have some basic knowledge of how the statements are tested. And many of you do. So for you guys, this will be, old hat. But hopefully for those of you that, don't really know about this, hopefully this will be good, useful information for you. So I want to start there. What is a requirement? Well, when your stakeholder says we need something, that's a requirement. I mean that, and how you write it, whether you write it as the system shell or whether you write it as a I need so that, or whatever way that you chose to write the requirement, That first level of writing we call narrative, where it's kind of like a paragraph. Somebody writes out kind of a paragraph statement. It could be even a bulleted statement. You could just say, needs this, needs this, needs this, needs this. At some point in the process, even though you might be done with writing it all up, you turn it over to a technical group, let's say, then they have to take it, and the project management term is decompose it. The business analysis or requirements engineering term is, I'm zoning out, it'll come to me here, abstraction. They have to abstract out of it a testable statement. And really, if you look at the journey of a requirement, the end before user acceptance testing is the actual testable statement. So I figured I would start there and just give you a sense of, what we've been dealing with for forever in business analysis, is that ultimately, whatever you start with has to become a testable statement, a test case. So what is a test case? Well, generally speaking, a test case has two parts. It has an input, which is called the main clause, and it has an output, which is called a subordinate clause. And what's fascinating about that is that without exception, almost every single requirement you're given is technically a subordinate clause. It's an output because that's what you're testing. Hey, we need the system to go faster. Okay. Did the system go faster? Then the system goes faster. But nobody tells you that. Nobody says, oh, by the way, all these requirements are subordinate clauses, and that you, the analyst, have to figure out the front side or the main clause. They don't always tell you that. And then a lot of times when they write them backwards. Like a lot of times you'll see the then result as the beginning of the statement. So it'll say, well, the system goes faster when these things happen. So it's like they've reversed the order of how actually that would be tested. Because when you go to test it, you'd say, when these things happen, then does the system actually go faster? Again, I didn't invent it. I'm just explaining it. So this is all fine and good if you've been trained on how to write a test statement. So generally speaking, let me just give you a test statement. Generally, a test statement has just an input and an output, but it can have more than that. It might have a precondition. So the way you think of the main clause, if you were including the precondition, is given precondition when, whatever occurs, whenever trigger occurs, then result happens. Okay. You could just have when trigger, then result. That's fine. You don't have to have a precondition. And that was our standard way that we wrote test cases forever and ever and ever. But how does that work with data? Now we're going to take you down a little bit further. So what we wanted to do is just kind of show you, first of all, this model. And on the left-hand side, those are your stakeholders. And on the right-hand side, that's your team. And for those of you that weren't in the last class, let me just kind of talk about the team really, really quickly. So on the right-hand side, and I'm just going down by the photographs, at the very top, I have my business analyst / product owner. And I know for a lot of you guys, that's a different job title. For me, it's the same person. So you'll just have to bear with me as I teach the course. I put those two together. Underneath, I have a project manager / scrum master. Underneath that, I have an IT person who's probably a system architect. Underneath that, I have a developer who's also possibly a subject matter expert. And then below that, I have a QA tester. And then at the bottom, you'll see an artificial intelligence picture, a blue person. That's Cortana, by the way. And that's intelligence. It's an intelligent assistant. And so this is the team of the future. And one of the things that we have to be prepared for is how to write requirements in order to engage the intelligence of the future. And those requirements, believe it or not, are going to be a mixture of both process and data. So starting with like a use case, you might have a process flow diagram and a data flow diagram. And for most of us as business analysts, if we're just following along with how we're trained with just the curriculum that they provide to us, and again, this is not a knock against the curriculum. it pretty much stops with an ERD, an entity relationship diagram. Unfortunately, all you're doing is learning how to build normalized transaction data, and that's many steps away from intelligence. So kind of in the last class or the last group, we sort of talked about how you fill in a little bit. We didn't really get too deep into it, but the journey from ERD, which is normalized data, then has to go into what's called denormalized or star schema, which I'm not going to get into in this class too much. But then once it's in that star schema, then it can go through a process of aggregation and summarization to build cubes on which to run dashboard visualizations. And then once you got that successfully figured out, then and only then can you add intelligence in the form of what's known as cognitive services, the picture, the voice when it talks to you, knowledge, things of that nature. So as analysts, because all of that technology has now been here for 10 years, we really need to be gearing into this direction. So it's not like we're going to go away from product and process. It's that we're now adding data. So it's process doesn't go away, product doesn't go away. We just now have to add data. And again, we were trained, and the way we train people on process is usually structured English. So let's just talk about structured English. So the reason you want to be aware of structured English is, well, first of all, I want you to think of structured English as simply one level below natural language. So we've got natural language is the way we talk to each other, and it's very nuanced and ambiguous. I'll give you an example. If I ask you to get me some water without really telling you how to do it, you could figure that out. You would go off somewhere and find a cup and or some container, doesn't have to be a cup, some container, and you'd find a source and fill it and bring it to me. And that all I needed to tell you was, I need water. Okay. Your stakeholders think that everything works that way. They think, hey, if I tell you I need water and you go get me water, how hard can it be for you to write that into software? And that's because they don't know. They don't know. They think it's an easy thing, what they're asking for. I need this, I need that, I need water. But anybody that's had to deal with machines recognizes how difficult it is to take I need water and then teach a machine to go do it. And initially, there's only one way to get the water when you first train the machine. Eventually, you want to have the machine be able to figure out every variation of being able to get water and bring it back. And all of that is done through data. So we're going to talk a lot about that here in a second. But generally speaking, the challenge is converting natural language to something that can ultimately be tested, which is structured English and structured query language, one level below natural language. And it's a modified form of English used to specify some sort of logic of an information process. And most of us, I'd say 99% of us, are used to what I call operational statements, just English phrases executed from the top down. Step 1, step 2, step 3, step 4, step 5. Great. In addition to those logical steps, you also have conditional steps, such as, if this occurs, then that happens, or if this occurs, then that happens, and else this happens, which are called technically extensions. And you have different kinds of extensions. You have exceptions, you have alternates, which we're not going to get into here today, but you go through that, and then you have, repetition blocks, which again are alternate types of extensions that will go along until they hit an exception and they stop. But what's interesting about this is that there's no standard tied to structured English, none at all. So there's no standards body that says we own structured English. So it's really kind of been developed on its own, and it's unique in every shop that you go into. So the way you guys write it, where you work, is correct, even though it might be completely different from the way someone else writes it at another shop. And so when I talk to people and they're like, well, what's the right way to write a requirement? I'm like, I have no idea. Just like when they ask me, how do I get it right the first time? I'm like, I have no idea. because every shop is different and they're all correct. So that's one of the challenges that we have, trying to convert natural language into something that's structured that it can be tested. So the key to keep in mind anytime you're writing requirements and working on requirements is that at the end of the day, it's got to be a testable statement. I'm of the philosophy that the analysts, and again, it's just opinion, but the analysts really should be trained on how to write testable statements from the beginning. And which is one of the things that I try to do in my courses is I try to teach everybody how to write a testable statement, because once you know how to write a testable statement, it makes it easier to actually elicit requirements from your stakeholders. And especially when you understand the structure of, okay, they're giving me the subordinate clause, they haven't given me the main clause. Now I've got information that allows me to go back and elicit, well, what are the main clauses that I need? And remember that your stakeholder may not know the main clause or what's driving the subordinate clause. They only know what the outcome needs to be. So I don't manage that. I just know I know what I need. You know, I had one client tell me, I don't care how the engine works. I just want to drive the car. So, and I understand that that's what your stakeholders want. They don't really want to know how it all works. They just want it to operate the way they want it to operate. All right. So a little bit more about structured English. It's a language syntax. I know many of you are familiar with it because a lot of us write requirements this way. Here's just an example for a business rule. For each customer number in the data store customers, for each loan in the data store loans that match above the customer number, and then it has a whole list of rules. Keep it running total, keep it running total, keep it running total, keep it running if the total amount past due, et cetera, et cetera. So this is pretty standard operating procedure. One of the things that I do in a class that I think is really helpful is I make students take this and actually put it into a test case and write out all the test statements. And it's really eye-opening. I mean, they go, wow, I had no idea. If they've never wrote a test script before, it completely changes the way that they view requirements, which again is the key to all of this is once you understand how to write a requirement as a test case, it will completely change the way you elicit and do all of the things that you're doing. Okay. Here's another examples of just structured English, one level below, and I'm running low on time, so I'm gonna kind of speed up this, but again, sequence of steps, simple conditions, complex conditions, and then here's decision tables, which again are usually associated with business rules. You might have one-to-many iterations, zero-to-many iterations, things of that nature. Okay, so that was structured English. All right, now I want to kind of jump to structured query language. And before we get into it, I'm not an expert on structured query language. I don't tell people that I'm an expert on it. I don't work in it every day. I know enough to be dangerous, which is, I always joke with people, business analysts are subject matter experts on talking to other subject matter experts. I'm a jack of all trades and master of none. But I understand enough to know that, I mean, I know what SQL does. I understand what it does. And I recognize that it needs to be used as writing requirements and building out test cases. So hopefully what I'm going to show you really quickly is just along the same lines of the given, given, when, and then. I'll show you the examples using SQL. All right. And then, but just really quickly, what is SQL? Turns out that it's called Dr. Cobb's Relational Algebra, which I thought was a really cool sounding name for maybe a stout beer. But it started out, it is a generic standard. It's really kind of generically owned by the ISO and the ANSI. It was about how to merge data. I mean, that was where it originated, was the idea of having separate data tables and how do we work with those data tables together to come up with, aggregation and summarization. It's a basic command set. It's relatively easy to learn, and it is. There's a lot of dialects out there, okay? Again, it fits into, basically, there's 4 categories, but there's 2 broad categories that most of us as analysts are gonna deal with, which is data definition, which is the creation of your tables, your field names, your, that kind of information. And the data manipulation, which is where most of us hear about SQL, is a data manipulation process. So you as an analyst need to be comfortable in being able to do both. You need to be comfortable in writing the requirements for creating an instance, which is another fancy name for a table, as well as writing requirements for querying data in order to generate results. Those are two things that you really do want to become comfortable at. I get more in depth in that in my class, but I just kind of wanted to give you an introduction to this if you've never seen it or not really familiar with it. But SQL is divided into components, including statements. So remember, a test case is a statement, and there's two parts to it, right? There's the front part, which is the main scenario, and then there's the back part, which is the subordinate clause. So there's the main clause and the subordinate clause. So again, statements which control transactions, program flow, connection sessions, and diagnostics. You got clauses and identifiers, you got expressions, you got predicate filters. Mainly what most of us are familiar with are what are called queries. And we're going to give you a couple of examples of those as we get towards the end. And SQL statements generally have a semicolon as the statement terminator. So there's a table at the top, and then underneath it, there is a diagram, and then underneath it is an example of just a statement, just something to look at. All right. Basic keyword clauses, it's create, read, update, and delete. It's the classic CRUD. And so you got, you create data, you got your read data. So a lot of the commands that we're using in SQL are meant to read data. So for example, to the right, it says select from, where, or by. That's a read data command. So you're reading a lot of data. And then the results of the data is what's used to then be aggregated and summarized, which becomes the reports that senior management are looking at. All right, so here's an example. And again, I try to color code stuff. So if you look, so red, I'm sorry. Red and blue are part of your main clause, and green is your subordinate clause. Or red and blue are your inputs, and green is your output. Well, in structured English, you might have a precondition and then a trigger. In data, you have an input and a process. That's where it's different. So you're given in structured English is a precondition. You're given in structured query language is an input. This is really important. Your when in structured English is a trigger, which is your input, and your when in structured query language is actually your process. And then both have a result that comes out of that. So for example, in plain English, so the command might be given an instance of product name, price, category, manufacturer, and then you have a dimension table, which again is just a fancy way of saying a table of data. So then you have your process, select all products where category is gadgets. That's your main scenario. Your subordinate clause, or your main clause, your subordinate clause, your result would be then return the results, product dimension table. And so for me, kind of color coding it and recognizing it, this is how I would write out my test case. Is I'd have on one side of my test case the red and the blue, and on the other side I'd have the green. All right. Here's another example with join data. And again, I don't have a lot of time to teach you guys SQL, so I'm just gonna kind of hit this quickly. But when you have two separate tables and you're trying to get data from them, you have to kind of join them together. And that's why it's called a join table. And it's technically called denormalization. You take normalized data and you put it together, you denormalize it so you can then run a report from it, aggregate, summarize out of it. But here's another statement. Given an instance of product, P name, price, category, manufacturer, and company, company name, stock price, country, dimension tables. So then your process, again, this would be your main clause, find all products under $200 and manufactured in Japan. Then your result in your test case would be then return their product names, P name, and prices. So everything in green is really what you're testing. And believe it or not, the things that are in green are also the requirements that your stakeholders are most likely asking for. So usually what they're doing is they're giving you the stuff that's in green and they're not giving you the other stuff. Okay, so I got 10 minutes, so I gotta go ahead and kind of get to the end. Here's one more example, same kind of concept. And again, I apologize for the short brevity of the presentation, but I'll send out a recording of it. And then if you want a PDF version of the slides, I'll show you my email and then you can just send me a request and I'll send that out to you as well. So, but here's another one. Again, your main clause, given an instance of product, and then count the number of products within the category, your subordinate clause, which is the requirement, then return the count in the category column. We need to know how many of X, Y, and Z have these things. Great. So that's kind of where it shows you. All right. Okay, so I had to bring it kind of to a close here because I only have a few more minutes. So if there's any questions, feel free to ask me now. You can text me, you can talk, you can, whatever you like. Anybody got any questions? Are you guys still out there? Anybody still there? Yes, okay, all right, cool. Let me just go back really fast if there's no questions. Okay, do you see writing requirements as SQL statements? Yes, I see you can write a SQL statement as a requirement. Absolutely. That's a great question. Here, I'll go back. I'll just show you really quickly since I only have a couple more minutes before this thing kicks off. If you look at this slide right here, so if you look at the SQL statements, the results of the SQL statements are going to be the requirement themselves. I got a question about too many times developers feel like we're trying to do their jobs if we write it as a SQL statement. I don't disagree. You're not trying to do their job. You're just trying to write. You can take a SQL statement. You don't have to write it as a pure SQL statement. That's the idea. You can write it as a natural language statement. So I don't want you to feel like you. And again, you're not trying to do that. Really quickly, there's all kinds of great online SQL. Just look it up on Google. There's a lot of free SQL locations. So NoSQL is, so let me talk about that. So NoSQL isn't really, there's structured data and there's unstructured data. So SQL is really about structured data predominantly, and NoSQL is really about metadata on unstructured data. So that's kind of the difference, and they're not really mutually exclusive of each other. I mean, if you have a data lake, 90% of your data is unstructured. So you're going to have NoSQL, and you're going to use a metadata system to kind of manage all of it. And then when you actually go to do aggregation and summarization, you probably will move some of that into a structured environment, depending on what the data is. So you may take data that's actually from your metadata files and move it into a structured environment to run queries against it. Any other questions? This is good. No, SQL is structured, just structured differently. Yeah, it is. It's structured, right? It's structured differently, right? Metadata. It's metadata. I agree. Yeah. There's a metadata structure to NoSQL, right? But again, the key here is that actual production. Okay. Again, I'm not going to argue. I'm not arguing. I'm just trying to keep it simple. Project requirements do not require database managers. Should SQL standards still be useful to display? Well, what I'm trying to do is get you to not necessarily write the SQL as a SQL statement, more to get it to write it like a narrative language. What I'm really trying to do is get you to understand that how do you embrace the concepts of SQL when you're writing a narrative statement? Okay, so you might have a stakeholder that wants you know, a report. That's fine. And the more you understand SQL, the easier it is to write the narrative statement so that when it goes to your developers and they want to turn it into actual SQL statements, they don't have to call you up and say, what are you asking for? Every time, and I find this interesting when people say, you're trying to do our job for us. What that really means is that they want to create work. And institutionally, companies are trying to mitigate work, the number of batch process steps each human is doing, which is why we're moving to data anyway, which is digital transformation. And people are fighting it, but you can't fight it because the technology is already there. It's like when people still had typewriters and email at the same time. And they didn't want to give up their typewriter, but even though they had email, they weren't leveraging the email. They were still using their typewriter. We still have a similar process that's going on today. So again, I'm not saying that. So how does that affect your? It doesn't affect anything, whether it's SQL structured or unstructured. The bottom line of it is that the result is however you whatever you're going to do to write the result. That's your subordinate clause, and the need statement from a requirement is generally a subordinate clause. When someone says, hey, we need this, whether it's structured data, unstructured data, structured English, what I want you to walk away with is understand, oh, okay. And then not only that, if you understand, oh, then the result is the subordinate clause. How do I write the full clause? How do I write both the main clause and the subordinate clause as an English sounding sentence so that everybody's aware of what you're trying to do? Hope that's helpful. Any other questions? Good. Yeah. Next time I'm going to SQL. I'm like, okay, cool. The next time I'm going to get in and talk a little bit about testing, and I apologize that I did not know there was a password. I think the Zoom added that to try to keep people from jumping in on stuff. So now that I know how to find it, I'll make sure that everybody has the password prior to attending. So, any other questions? All right, so let me give you my email. If you want the PDF, just put this out here for everybody. Okay, so go ahead and if you'd like the PDF, just please, just write PDF for today. I already know, that you were online with me, so, and I'll send that back out to you so you can at least look through it. So hopefully that was helpful. So, all right. So with that, let me go ahead and I'll wrap it up here.